Hello and welcome to a tutorial covering both half adders and full adders to do with computer science. And one of the most important things to be able to learn about being able to work in logic is the ability to be able to understand Boolean mathematics. And computer systems are basically just billions of on and off switches. So I'm going to quickly show you how to be able to construct two essential circuits that will be used at both GCSE and they expect you to be able to know these circuits at A level as well. So we're going to use a piece of software which is actually called Digital Works. And the Digital Works, I'll just move myself into the corner so that you can see a little bit better, is actually a software program that is available for free. So you can actually download this as a student and to be able to use exactly the same piece of software that I'm using and to be able to follow through on the tutorial. And so typically on your GCSE and your A level, they would expect you to be able to understand in computer science how to be able to identify both the logic gates and to be able to construct them into a simple circuit. Okay, so here's the interface that you can see from the top. And you've actually got various different logic gates here. It is a very comprehensive program that you can actually use, but we're just going to use some of the simple aspects of it to be able to help you understand about what digital circuits are and how to be able to construct both a simple half adder and a full adder. So the first circuit that we're going to use is a half adder, and it's basically just two simple logic gates. You have this one, which is an AND gate, and we've got two inputs on the AND gate and one output. And the other gate that we're going to use is called an XOR, which is an exclusive OR gate. Now this piece of software allows us to be able to provide some LEDs for the output to be able to see exactly how the circuit's working. And that's one of the beauties about learning with Digital Works, is you can actually construct the circuit and then you can run the circuit and actually see it working. And so here we go. We've got our XOR gate here. And let's just put a name on it. So it's the X and the OR means that it's exclusive OR. And we'll just align that a little bit better. Make sure that we can see it nice and clearly. And the other gate that we're using is the AND gate. So again, we'll just align the label to make sure that it's nice and clear. So there's our exclusive OR and now our AND gate. And then it's just a matter of being able to simply wire them together. So this circuit is actually called half adder. And it only is constructed from two gates. Remember, this forms some of the fundamental basic circuits of computer systems. So there's our half adder circuit, which is an XOR and an AND. So I'm going to put a couple of interactive switches on it. So there's our switch number 1. There's our switch number 2. Here's our wiring tool on this side. We're just going to simply wire up the circuit. So remember, they are interactive inputs. And these are the outputs for our LEDs. So those LEDs will light up when we run the circuit. We'll be able to see whether the XOR or the AND is actually firing as a gate. Now then, our AND gate here is actually going to connect straight into our inputs of the XOR. So here we've got an input, and we'll put that in as A. And our second input we will put a label on as B. Okay, so the final part is just to put a label on for these two outputs. So the first output is actually the sum, and the second one is called the carry. So this is the sort of notation that you'll get in your exam, and they expect you to be able to identify them. So we've got sum and we've got carry. Now then, what's really interesting is we can actually run the circuit. So here we've got basically our run command, And then we've got an interactive hand here that we can actually switch on these various different interactive inputs and see what the output is. So the first one is we're going to put a single input on the A, which means that it runs through our XOR gate and gives us a sum. So any single one, either A or B, will actually give us a sum. And when we actually have both of those on, which is A and B, it gives us a carry. So what does this circuit represent? It means that the sum represents the number 1 and the carry represents 2. And it's just counting two binary inputs of A or B or A and B. And that's our half adder circuit. And so the next question would be, well, what's the difference between the half adder and the full adder? Well, if we actually just stop this circuit here, if we copy this in its entirety, and we can paste it side by side, having two of these circuits together, excuse me, can actually allow you to be able to count not just 2 inputs, but actually 3. So this will be converted to, I'll just edit this annotation. So this is now going to be our full adder circuit. So all we've done is duplicated exactly the same sort of things. So we'll get rid of these interactive switches here. And this one. We'll get rid of those 2 LEDs. And all we're going to do is connect up each of the inputs straight across. So here is our XOR. It's going to connect up to the output of that XOR. And here we've got this third input. We'll pop it in here. And we're going to connect from that side. And we'll just make this a little bit easier to be able to follow through. So I'll just bring it down slightly. And connect into that interactive switch. So this one now will be labelled as C. So we've got 3 interactive inputs, A, B and C. So there are binary inputs. Let's just align that, make it a little bit better. So here's our inputs A, B and C. 3 inputs, and again we've got 2 outputs. Now the output of these 2 AND gates we're going to actually put through on an OR gate. So here's our OR gate. We're just going to put this on that side, we'll line that up. We're just going to wire this up. And we'll put another LED on that side. Again, we'll wire that. So what have we got? We've got a half adder here with an XOR and an AND. And we have another half adder here with an XOR and an AND. They're combined together and wired up so that the 2 AND gates come to an OR gate. So that OR gate is going to be our carry. And this one is going to be our sum. And so the difference is, our half adder circuits would add together 2 binary inputs, but our full adder circuit will add together 3 binary inputs. This forms part of the fundamental circuits that form part of a CPU, central processing unit used in our computer systems. So let's run the circuit. Let's see how it works. So again, we're going to run and use the interactive finger. We'll turn these 2 off. So with no inputs, you don't get either a sum or a carry. Any single input will give us a sum. That's A switched on. There's B switched on, again with a sum. And a C switched on gives us a sum. And what will happen if we have 2 interactive inputs? So we've got A and B switched on, which gives us a carry. We've got A and C switched on, which gives us a carry. And the last one would be B and C, which gives us a carry. Now then, what do you think would happen if we switched on A, B and C? Well, let's try it and find out. There's A, B and C switched on, and we get both a sum and a carry. So the sum represents the number 1 and carry represents number 2. And so what we have here is a circuit that will add a combination of 3 inputs and give us a suitable output. And that's our 2 circuits to be able to help you for your GCSE in computer science and also the A level in computer science as well. At A level, they would expect you to be able to draw a full adder circuit and to annotate it just as we have done, showing the logic gates of XOR and the inputs, and you can label the inputs A, B or C, or any sort of designated character that would identify them, and you sum and you carry, and that would give you your suitable marks. Probably full marks if you include definitely the truth table to go with it. Okay, thanks for listening. If you've got any queries, you can always get in touch with me. Thank you very much for watching.